Before going into the isometric projection, let us have a look on the 3D model that has been generated by using AutoCAD software. So let us go over to the 3D session over there, and afterwards come back to this projections. In the 3D session, you can observe the model that has been generated by making use of an AutoCAD software. You can observe the platform with the tapering on all the faces, on all the sides. The tapering is there on all the sides. This is the front view with the cross mark. The side view. Let us have a front view. This is the front view of the given problem. This is how it looks. This is a elevation that has been given in the question, and the top view. This is what that has been given in the question with the naming, and we have generated here a 3D model for this so that it becomes simple and easy to understand. Now this with color, we can see the top view. So before going into the problem, to draw the isometric projection, have this view clearly in your mind so that you can understand it, how to draw the projections in the problem. Now let's go into the projection of isometric projection of the model. Yes. Now after having a look on the 3D model, I think the picture is very much clear in your mind. You got an idea how exactly the model will look like and would come out after drawing the projections. So first you have to, as usual, you have to draw the isometric scale for drawing this, which has been taught in the very beginning of the sessions of the isometric. So go back to that, have a look on that video where we have said about the isometric scale. Have a look. Afterwards, come back to this and start drawing the projections. So as it was said earlier in all my other earlier sessions, we'll be normally looking from this corner, and we're going to place this on the left side and right hand side to view the right and left view of the section. So let us start with the horizontal line. Now come to position B1. From when you just measure this length, it's 50 here and 80 on this side. You're going to mark this in the isometric projections with B1 A1 on left hand side, B1 C1 on the right hand side. Now you can complete this rectangular block in the isometric projection. Now you got the point D1. So base has been prepared now. The platform A1, B1, C1, D1 has been prepared, drawn. Now we are going to measure the height. Let us draw the rectangular block. Therefore, we need the height. Measure this height 25 mm. Take the iso length, mark it over here, and name it 1, 2, 3, 4. It has been already named in the question itself. There is no need to you to name it as it was done in other sessions. It has been already named. Just give respect for that naming and mark all this 1, 2, 3, 4. Then complete the rectangular surface at the top. Now you have prepared, they made the box here, rectangular box or a block. Now you have to get this top face A, B, C, D. You have to get the top face A, B, C, D. For that, you measure this horizontal length from here to here. It is 80 minus 60, you'll get 20, minus divided by 2 on either side, you'll get 10 mm here. So here 10 mm, this side 10 mm. Let us mark this line AB. You're measuring this length, mark it here and draw a line. All these are lines are drawn only for the construction purpose. Afterwards you can erase it out or you can leave it there itself. Now measure this side, right side, that's also equal to 10 mm. Mark it on the right hand side. This is the constructional procedure to get A, B, C, D. Now measure this. It's given as 50 minus 30, you'll get 20 divided by 2, 10 on either side. So mark this length here, draw a line for that. Similarly, draw a line from the top, in the top view, you mark it on this side. Now you got the ABCD on the top surface. ABCD has been marked and we have obtained that on the top surface of the rectangular block that has been generated. Afterwards, these are the tapering lines. We'll draw this at the end. All these inclinations, we'll draw it at the end. Now I want to get the cross. It has to be placed at the center. This width is 30 mm minus 10, the thickness of that cross bar, divided by, you'll get 20 mm, divide that on either side, you'll get 20 mm. So let us get this line. So measure this horizontal width 10 mm. From here you mark 10 mm, ISO 10, get the line. Similarly, draw a line here, get this line in the isometric projection. Now if you want to get this point, from here to here the distance is 60 mm minus the thickness of this cross, it is 10. So 60 minus 10 is 50, divided by 2, it's 25 this side, 25 this side. To get the position here, let us measure this 25 mm here, get the ISO length, mark it here. Similarly, you can get this length, we'll get this line. So we got the bottom face of this cross, this one. So from here we can start drawing this vertical lines and get the distances. Measure this height. Totally it's given 60 minus 20 minus 10, will get 30 here. So get ISO 30 and erect a vertical line here. ISO 30 at this position. On either side we have erected it. It's of equal length. Then you can get this horizontal lines here parallel to 30 degree in isometric view. Measure that length. It's 15. mark it over here. So this is 15 on either side from this corner, that is this corner. Then erect a vertical of height equal to 10 mm in the front. Then this length, as usual, it is known 15 mm. The same thing could be marked. Then height of this top crossbar is 20. You mark that ISO 20 at the top after measuring it. Close it. It's 10 mm here, mark 10 mm here, and automatically it will come over there, because in the beginning itself you have taken this as 10. The front face of this cross is now ready. You have to mark it has got a thickness here. As you observe the plan here, it has got a thickness of 10 mm. So let's start drawing all this width equal to 10 mm. So I've drawn 10 here, take on the vertical, it goes there. Then we'll draw 10 from here. From all the corners, I've drawn a line parallel to this 30°. That means these lines are parallel to this AB line or A1B1 line. They are placed at an angle equal to 30°. Therefore, all these lines are parallel to 30° horizontal line here. Then you can join them in sequence. Join it. Now almost the model is ready now. A draft has been done. A rough sketch has been done. Now once you come to a conclusion that it is finer, you can start darkening or thickening the lines which are visible. Now these edges are inclined, that is AA1, BB1, that is AA1, BB1 or A1, B1, B1C. All these are thick lines. Let us start drawing it by one. Now B1, A1, they are the baseline. You can see it with a thick line here. Then you can see the tapered section, that is A1, A1, you're going to draw it like that. Similarly B1 here, then CC1, DD1 is at the back side of this model, therefore it is not seen. I am not marking. If at all it is seen, you could have shown it with thick line, or you can show with dotted lines here. All this base it could be shown with dotted line if we are interested, or otherwise there is no problem. This construction line you can retain and leave it as it is. Now I'll come to the finalization of this one after completing this. These lines. Now let us start drawing the vertical line. So we come to know that front face is completely seen. We'll mark it by thick line. Yes, this completes the front elevation of the cross. You can see the back side, all these thicknesses could be seen. So you can also mark it with thick line. Yes, now the back line. So almost this is completed, except this portion. From here to here you can see it, and here to here you can see it. This line is not seen because this cross is covering up. Yes, this is the final isometric view of the given problem, that is you have been given with the top view and the front view, and this one we have made this into a 3D model like this and call this as isometric projection, because all measurements are being taken with respect to the ISO length. If the same diagram was drawn for the true length, this would have been called as isometric view or isometric drawing. I'm repeating all these things again and again. Especially with civil engineers, you can learn how to draw the dams and bridges, all these things. It becomes very simple for you if you understand this basic concepts. Now let me eliminate the construction lines. Yes, I've eliminated all the construction lines, and this could be taken as the final view of the model. Hope you understood the concept of drawing the non-isometric lines like AA1, BB1, CC1, DD1, all these things. All these inclined lines are called non-isometric lines. To get that, we are gone with offset methods. As you observe here, the method was followed in our procedure and made it simple. Hope you understood this. Thank you very much for watching this video. If you are not subscribed, please do subscribe at least now. Thank you once again.